All right, there we go. Now we're ready to rock and roll. Well, welcome to day two of SOC Core Skills, or we like to call it Infosec Nostalgia. It's just like that book. Oh, great. Going into it, Ready Player One, where we completely have nostalgia for video games and the culture of the 80s and 90s, because that's clearly where we peaked. But what we're going to be doing is we're going to be talking about another technology as we close out a little bit of the network section from yesterday. We're going to be discussing ASNs. That is our next lab. And then we're going to move into Linux and Unix. Now, why are ASNs important? So ASNs and you, to quote and paraphrase another 80s movie. So ASNs, I want you to think and understand them in terms of like zip codes for the internet, right? So with the internet, you have all of these different areas of responsibility. There's over 60,000 ASNs, and these are predominantly for internet service providers. They're predominantly for large corporations like Microsoft, Google, Amazon, and all these different companies, and they break the internet up, and different IP addresses go to different places. And honestly, the mnemonic device to kind of understand how this works is very apt to the Postal Service. If I send a packet, I need to get it to, let's say, Istanbul, not Constantinople. I need to get it there. I don't care about the path the package is going to take. There's going to be a whole bunch of different post offices all over the world. They're going to route it for me. So I'll put in the country and the address, the zip code, all of those different things. And then my post office and postman or woman is going to route it properly. And it's going to go from place to place to place. Now, we use a number of different protocols like Border Gateway Protocol that allows us to route packages and stuff, but it's going to route it to areas of responsibility like ASNs, autonomous system numbers. And these numbers say, I am Microsoft and I am responsible for all of these for Xbox like updates and things like that. I am Microsoft and I'm responsible for all the ones for Entra. I am Microsoft and I am responsible for anything in Azure and cloud services. You have different ASNs for different responsibilities, and your system routes that traffic. All that being said, there are good neighborhoods and there are bad neighborhoods. There are different ASNs that are very dangerous. A lot of malware comes from them, a lot of C2 traffic goes to them, and a lot of spam comes from them as well. You often hear about like deny lists or bad lists of IP addresses on the internet as a whole. And if you look at these different IP addresses that are deny listed, you'll start to see that a lot of them show up in the same ASNs. This is important for understanding networking. It's also important for understanding how we can deal with standard incident response and threat hunting. So that's going to take us right into the next lab of understanding ASNs, which is right somewhere. There we go. Understanding ASNs. We're going to go into that lab. Let me share this lab with all of you so you know what we're getting into. There we are. All right, so what we're going to do is we're going to take a look at what are some of the worst ASNs on the internet. The first thing that we're going to do is we're going to wget and we're going to pull this deny list kind of conglomeration. I'm going to do the first steps because one of them takes a little while to run inside of your VM. It's going to take a few moments. There we go. Looking good in the neighborhood. Open up a Kali terminal. There we are. I'm going to go ahead and change my appearance settings. There we go. All right. So I'm going to wget and pull down from GitHub a list of that's constantly being updated of quote unquote bad IP addresses on the internet. Then I'm going to download all of the ASNs associated with those IP addresses, and I'm going to send that to Kimry. It's Welsh, that's how it's pronounced, through their Whois service, and it's going to pull down the ASN names for every one of those IP addresses. We can pull down the ASN numbers. This is going to take a little while. I'm going to let that percolate like Julia Childs in the background, and then we're going to do some basic sorting on those, and you're going to see which ASNs in the world are some of the most dangerous ASNs out there as well. This becomes critical when you're researching potentially bad IP addresses to get an idea of where that IP address is and just how bad that ASN actually is as well. All right, so with that, let's go ahead and let's set the timer for, let's do 15 minutes, Daryl, and we will resume because it takes a little while for this Kimry lookup to fire and work properly. And we'll be right back, and then I will continue. See you at 20 after. All right, we are ready to go. All right, so I've already gone through the Kimry step. And now I can start doing the sorting step. So what we're basically doing is we're taking all of the ASNs and we are going to print out the overall count, and we're going to print out the ASN number, and then we're going to look at that name and we're going to sort unique. There we go. So what does this tell us, and why is this important? Well, if we look at it, we have cloud services like DigitalOcean has 9,155 deny listed IP addresses in that database. Then we get into Alibaba, we got 2 from China, and then we get into Microsoft and then Google. If we're looking at DigitalOcean, Microsoft, and Google, those are all their cloud hosting services where they are actually hosting virtual machines that people put up. This is one of the key problems that you begin to understand whenever it comes to cloud computing, is that it's very, very, very easy to stand up technology. You still need to maintain and secure that technology. And clearly, that isn't happening at a rate that it should be happening on that as well. But if we start dropping out of that, we can start seeing a lot of different other places that look like some pretty rough neighborhoods out there, But I want you to notice something. Okay, this is kind of weird, but I want you to notice. Notice how quickly we go from 9,000 to like a few hundred. There's a very steep drop off. If you look at the overall internet, it is a very few small group of ASNs that have a lot of deny listed IP addresses. As I said, there's something like 65,000 ASNs. That has nothing to do with 16 bits. It's just the number of them. And if we're researching and we're looking at IP addresses, when we go to like Shodan and we look at SCADA, we look at potential Mongo databases that are potentially compromised. I don't think the tag works with my account on this account. But if I go to Mongo databases, you're going to quickly see that a lot of these tend to be in ranges that have a lot of compromised systems. And this becomes more important a little bit later when we start doing beaconing analysis with AC Hunter and Rita, which is coming up a little bit later in this class. So understanding ASNs and understanding and thinking of them in terms of zip codes, and understanding that there's bad areas and there's relatively benign areas on the internet really starts to help understand how the network of the internet is kind of stitched together from a computer security perspective. And that's the goal of the lab. All right. So any questions on that before we move on? I want to get into the Linux section next, but before we do, I would like to answer any questions that you all have relating to what we just did. We got Roswell and PatCam and Sin all chatting. So who creates the ASN? So you have IANA and a number of different groups and ARIN that basically break up the responsibility and assign those IP addresses as well. How does ASN relate to BGP? Excellent question. If we're going to talk about BGP, we've got to talk about a couple of different things. But before we do, we're going to talk about the traveling salesman paradox. Okay. So if we look at the traveling salesman paradox, I want you to think of a traveling salesman that has to visit 15 places. All right. If that traveling salesman is going to a specific place, right, then there's an almost infinite number of different ways to get there. This is what we call a non-probabilistic hard problem in mathematics, which is weird because do you know what creature solves this problem almost instantly? That if you look at how this is set up, like let's say you're visiting multiple places, they will always find the most efficient path to do that. Any takers? Bees. If you look at how bees visit flowers, they almost always go in the most efficient path to visit all of those flowers, which is wild because it is a mathematical problem. Now, when you're looking at like mold and mycelium, it'll create a path that'll resemble like a subway system. But as far as visiting, it will be bees. They will do it pretty much set up. It's weird. My lighting on Zoom is now all messed up again. I've got that Oompa Loompa glow. But bees do that. So this is a problem. So if you're looking at the internet, you have hundreds of routers that are routing traffic constantly on the internet, and this definitely becomes a non-probabilistic hard problem. So the first person to actually solve this that we used in early computing, and we still use that same protocol today, is Dijkstra. Dijkstra was a computer scientist who developed an algorithm called the open shortest path first algorithm, which means that we don't have to find the most efficient path. We just have to find an open shortest path and then just use it, right? It doesn't have to be refined for perfection, just has to kind of work. And that's kind of how routing protocols work today. They try to find the best that they can in the time that's allowed associated with it. The other thing that's really interesting about Dijkstra is there's a lot of, like, Dijkstra never used a computer. He dictated a lot of what he was talking about in computer science to his secretary. And there's some thoughts that his secretary is one of the people that helped come up with open shortest path first algorithms out there as well. So very cool stuff when you're talking about routing and things of that nature. All right, let's get into Linux. All right, so Linux is actually my favorite operating system. I know it seems weird because, I'm using a Mac, right? And the reason why I use a Mac is because I travel a lot and I need to travel with a microphone and a camera that is pretty good. Not the best, but pretty good. Oh my gosh, does anyone want to know BGP hijacking? Or ASN prefixing attacks? Does anyone want me to talk about those? Kishin Infosec? Because I can talk about that. All right, cool. BGP prefix attacks. If someone can find a Wikipedia article and share it, that would be awesome. I will describe it. All right, so we got all of these ASNs, right? And these ASNs, some of these ASNs are big and some of them are small. Some of them have lots of IP addresses. Some of them have very few IP addresses. Some of the ASNs only have one IP address in them. So let's say that there's a conflict. Let's say that you're trying to route traffic and that IP address exists in two separate ASN numbers. How does your system, or how does the system determine which ASN wins? Turns out the more specific ASN wins. So if I have one ASN that has 1,000 IP addresses and I have another ASN that has a single IP address and there's overlap with that IP address, the one that has the fewer number of IP addresses will be the one that wins that game of rock, paper, scissors. So if you want to do BGP prefix attacks and you want to hijack BGP traffic, let's say I want to reroute all of the traffic for Department of Defense or something like that. Not that I would, I'm just using it for articulative and educational purposes. If I was an ISP, which there are thousands of them, I would broadcast an ASN, route it to my router, and I would route that one IP address that I want to hijack in a different part of the network on the internet, and that traffic would be routed to me. That is BGP prefix attacks. So very cool stuff. All right. Very good. All righty. So let's talk about Linux. So as I said, Linux is my favorite operating system. I use Mac specifically and only because I need a good microphone and I need a pretty good camera with me. I don't want to carry a microphone. I don't want to carry a camera. I just want a good, solid notebook computer. They're also made out of machined aluminum, so they're very durable for travel as well. But when it comes to just raw operating systems, I'm just really a super fan of like Linux. I just am. In fact, I run Linux as a virtual machine through Parallels in a lot of my systems on that as well. So we're going to be going through, we're going to be talking about incident response and how to detect malware on a Linux computer system as we progress through this section. So when we're talking about Linux and Unix, it's important to kind of understand which directories we're actually dealing with and what is in those directories and how those directories actually work as well. So I'm going to give you a quick tour. So we're going to go CD to the top level directory. And if I type ls, I have a lot of directories. We have 0, which does nothing in this situation. I have CD intro labs. That's where my labs are. But I'm going to go to bin. because that is my first interesting directory. And if I type ls, I can see all of the binary files on all of the binary files that exist on the system. Now, these are just straight up binaries that exist, right? Just straight up binaries that we have. Question was, what is my favorite distribution? I love Debian distributions. They are my favorite distros by far. So if you look at binaries, like one of the things I'm using right now is my command prompt, and that is my bash shell. Actually in Kali, it's Z shell, but bash is another shell environment that I can work with on that as well. But we have all of these different binary files, and we put all those binary files in the bin directory. So if I back up, I type ls again, let's go into boot. So this is kind of cool. On Linux-based systems, when you update your operating system, you update your kernel version. And what it does, it literally downloads another like kernel and it keeps the old kernel there. And some type of bootloader, like you can see, we have grub and we have EFI, will be used to help determine which kernel you use. This is really, really super cool because if you need to roll back or you have a problem with your distribution as a whole, it's really super duper helpful to be able to roll back to a different operating system kernel. And you can see the kernels right here in this directory. So if I go back again and I cd into dev, the important thing to take from this is everything in Linux and Unix is a file. Your kernel is a file, your memory is a file, your keyboard is a file, everything is a file. And in the dev directory, these are all of your devices that exist. These are device files. For example, if I do tty, it's going to come back and it's going to say, I'm running dev pts sudo teletype terminal 0. So we have all of these different terminals that exist. I have things that I can play with too, like I can cat. Let's do urandom. If I cat out urandom, my system's just going to generate random gibberish. Here in a second, it's going to freak out, starts going putty, 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 putty over and over and over again because the terminal is puked all over itself. I can go Control C. There we go. And my putty session has died because I basically just flooded it with garbage. So now if I go back, I can reopen it. Here we go. There we go. We're back in it. But the point is, anything associated with devices is in the dev file directory. So we have all of our devices there, present and accounted for. If I cd back to the top level directory, type ls, I can move into etc., etc., etc. So the etc. directory is where configuration files exist. This is really helpful because if you're working in Linux and Unix, it's very common for the etc directory to be where your individual configs exist. Now, you may have an opt directory, which I'll talk about here in a little bit, for self-contained binaries, but there will still be many times an etc. directory that exists. But if you want to know your configuration for your web server, it's usually an etc. If you want to know the configuration for like GIMP toolkit, it's an etc. If we want to do what do we got? GNOME configs, all of that exists in the etc. directory. Now, this is one of those reasons why I prefer Linux and Unix over Windows. And the reason why is because Windows notoriously puts configs in a wide variety of different places. You can have config.ini files, you can have registry files, you can have alternate data streams, you can have any number of different places that exist on your Windows computer system where configs can reside. And with Linux, it makes it a lot easier to work with. The next one would be home. That's just where your users exist. So I have the Kali, that's except for root. Root has their own home, and I'll show you that here in a second. And like your home directory is like where you keep all your stuff, man. It's like where your configs, your desktop files, your downloads, your documents, they all reside in your home directory. Lib has nothing to do with politics whatsoever. And if you look, we have lib32, we have lib64. Those are libraries. On Windows, they're called dynamic link libraries. On Linux and Unix, it's called a shared object library. And if you want to think of these like libraries, just literally, that is a very good mental model. Because if you remember in the boot directory, we had the kernel. And if you looked, those files are really small. When that kernel starts up, it loads additional functionality as needed. This gets into macro kernel and microkernel architecture arguments, which are way above my pay grade. But the idea is when a kernel starts up, you can load libraries and functionality into the kernel dynamically as needed. So if you're on a computer system and you go Control C, you start copy. Your computer needs to go grab the library to pull in that copy and paste functionality. And it does this through dynamic linking and all kinds of different things under the hood. But all of these libraries exist so your computer system, as needed, can load that functionality in. It'd be a lot like a real library. If I want to find something like, let's say I want to look up a book, cats and hats, I can go to a card catalog system, pull open C, go to the cat section, and find the book usually associated with the topic that I'm looking for. And it would have a specific section in the Dewey Decimal System in that library where that book would exist. Your computer is using something very similar to that to update its functionality all of the time. And we have 32-bit libraries, we have 64-bit libraries as well. Lost and found is just, temporary files that disappear and come back. We also have temp that we use for that as well. Media is for media. It's one of the things that I hate about newer Linux systems is it's supposed to be under mount. That's where God wanted you to mount things. And it was an 11th commandment that fell off, that was kind of a bit of a frustration for Moses back in the day. The bush was on fire. He was high. He was talking to God, fell off. But that rule was basically thou shalt mount things on your operating systems in the mount directory, but we lost that. So a whole bunch of different distributions try to create directories like the CD-ROM directory, the USB directory, or the media directory, and things like that. Yes, there are hidden files. We're going to be getting into that in a little bit. Cold start, just sit tight. But this is where Kali likes to put media, even though I hate it. Mount, as I said, is where God wants it to be. Now, opt is for the programs that are completely self-contained. This is where they will have their etc. directory. This is where they'll have their bin. This is where they'll have their sbin. It's all going to be tied in one nice, neat little directory where all of those files are associated with it. So if you're looking at in packet, you're looking at honeyports, password cracking, responder, I just put it into the opt directory. And there's no hard and fast rule for opt at all. Proc, proc is wicked cool. We're going to have a lab with proc in a little bit. When processes start on your system, they're given a process ID or a PID, okay? Process ID. Now, the proc file system, if I CD into one of these directories, is what exists for that process in memory. It doesn't actually exist on the hard drive. But you can look at this. We've got the architecture, the attributes, the current working directory, what the executable is, memory mapping, all of this exists on this system in memory for this specific process ID, which is awesome. And this becomes really important a little bit later. Whenever we're talking about malware hunting, we can actually go into the process IDs and we can do a lot of analysis on that as well. And we'll show you how to do that here in a couple of minutes. Root is just root's home directory. That's all it is. It's like home Kali. It's just root. Run is for running different containers. Same thing with snap. Another big problem that exists in the world of Linux and Unix today is all of the ways that you can run packages. So you'll have like Debian files, you have Yum files, you'll have apt packages, you'll have snap packages. There's just tons of them that exist, which is kind of frustrating. And they even do it in like different coding languages like Golang and pip in Python, which is kind of frustrating on that as well. SBIN is for system or service binaries. These are binaries that you'd use specifically to maintain and do things with the operating system. So if you're looking at like iwconfig, that's for wireless configuration. WPA CLI and WPA supplicant is more wireless stuff. Just a bunch of different things in that. Zip to John I don't know why the hell that's in here. I don't know. That actually shouldn't be an S bin. I don't know why the Kali people, that should be in bin, but whatever. You have all of that available, but these are generally for things where you're maintaining and you're updating the operating system. So there's a lot more to this, but these are kind of the general overview of where these directories are and what they do. And I do not expect you all to just basically know this intuitively moving forward. So if you notice, most of what I've been doing, I've been running, and I have my wonderful little command prompt right here is a $sign. That means I am not root. If I do ID, it says that I am Kali. If I do who am I, comes back and says I am Kali. And that's because I am not root. Now, if I want to become root, I can become root by sudo su space minus. That means switch users and do something. In this situation, switch users. Why am I doing it that way? Because if I just do a straight su, I have to know root's password. If I do sudo, I'm in the sudoers like wheel, and that allows me to run programs as root. And when I run it, I just have to know my password. So that's just the way I do it. There's a number of different ways that you can do that. And you can do that. By the way, the buzz, do you want to see another way that we can find hidden files? I can hide it better than that. We talk about dot files. I'll show you guys a trick on how we can really hide files in a little bit. All right, so that's becoming root, and that's the different permissions that exist on that as well. Okay, let's do the hidden files. We're not going to do it now. We're going to do the lab, and I'll show you a trick here. So if I create a file, if I do touch John, okay, that sounds a bit dirty. Sounds weird. That didn't go the way I wanted it to do. All right, I'm sorry about that. But if I type ls, you see that there's a John directory. All right, so I just created a file using the touch command. So I can, by the way, there's all kinds of problems with commands like touching files. Like that's kind of weird, right? So I can do touch. Let's do this. Let's do touch dot John. And let's type ls. Only John shows up. If I do ls minus a, it's going to show me both the John file and the .john file as well. You see, on your Linux and Unix system, there's a number of files that are like for configs, like bash rc, we've got cache, we've got IPython, we've got local, Metasploit. These are all that are, they're configs. I don't want to see them every time I'm in the directory. So they hide them or suppress them so you don't see them all the time. It doesn't necessarily mean they're evil. It just means that it's being suppressed from showing it to you. All right. So that's how we show hidden files. But I'm going to show you something cooler than that. If I want to make a directory, I just do make dir and then the name of the directory, and then it creates it for me, which is kind of neat. I can also do finding files with locate. In your Linux system, let's do this. Locate.john. And it found one file. Now, notice it did not find the .john file. It was able to find user share icons, flat remix blue dark, app scalable com.github.john factup. So this is an image associated with, having a full GUI on the system. So I'm going to run update db and I'm going to let that run. And what it's doing now is it's going through and it's indexing the entire operating system's file system directory. So now if I do .john, it found two. It found the .john file and the other one. So this is really helpful whenever you're trying to search for different files on your computer system, because there's this indexed directory of all the files on your computer. So very, very cool to basically hunt down things on your system. Now, editing files, we use VI predominantly in this class. I also talk about Nano. I'll talk about both of those here in a couple of seconds. But if I'm in VI, if I go VI John, because I just created that file, right? I'm now in VI, and VI can be very frustrating for people that are just getting started in Linux and Unix, but you have to learn it, right? You have to learn VI. Not the hero. VI is the devil. Not going to disagree with that. I'm not going to get into your religious preferences on that as well. But the question is, why would I, even if VI is quote unquote the devil, why would I say that VI is absolutely something that you need to learn at the most basic level? Why would it be so critical for you to understand the basics and fundamentals of VI? Got some people typing in because it's on all the machines. It's on all the machines. So I've created a little cheat sheet for you. I can use the A key to start editing, and I can just type stuff. Yay, look at me, I'm a hacker. All right. Now, at this particular point, I'm in insert mode. Okay. If I want to exit, okay, this is the big thing. People are like, you're a computer person, exit VI. That's a pretty good indicator that somebody's actually a computer person, to be honest with you. So if to do this, I am in insert mode. So what I want to do now is I hit escape. And now I'm no longer in insert mode and I'm not typing. So if I want to exit, I hit shift colon. Now I'm sending a command directly to VI and I can type WQ exclamation point. That means write, quit, don't worry about any errors that are presented. And now I'm out. And now I can less out the John file and there's all of my gibberish, right? So pretty easy to use. These are the things that you need to know. If you know how to do these, you'll be able to survive on Linux just fine. However, for a good number of you, you're probably going to use Nano. All right. And the reason why Nano is so important, all these people are sharing Vim cheat sheets. If I go into Nano and I go Nano John, I want you to look at the bottom of the Nano screen. And if you look, Nano has like built-in help right in the bottom. So if I do stuff, right? So if I do stuff and I want to save it, I got this little thing. It says, okay, you want to write out, I need to do control and O. That little caret that you see is a control. So I do control O, and it's going to be like, do you want to write it to John? Yes. And I just wrote the one file. If I want to exit, the little help is right there. And I could say control X and I exit. So Nano has all of these little helpful hints right at the bottom for you to be able to use it properly. All right, so let's talk about processes, right? So if I'm on my system, I can run PS. I want to show you some differences in how switches modify what we're doing. If I run PS is just going to show me the processes associated with me running right now. I've got sudo, I've got su, I've got z shell, and PS. That's literally all of the main commands that I'm running at this point. But through the power of little switches, I can change what PS shows me. For example, I can do PS AUX. That basically means I want to see all processes now, sorted by user, and I also want to see the ones associated with teletype terminals with the X. If I hit enter, I've got all of these processes. I've got the user, the process ID, and I have including the ones associated with teletype terminals. So that switch allows me to really drastically change what it is I am seeing at that moment. But there's more than one way to do the same thing on Linux and Unix. There's a lot of different ways. See, I can look at processes with PS. I can also run top. If I run top, top is a lot like Task Manager and Windows, where it's going to show me all the processes that are currently running on the system, their process ID, the user. It's going to sort them by CPU usage, and I can see it updating dynamically. I think every 3 seconds it should be updating. That's pretty cool, right? So I can see that easily. And yep, I don't think I have HTOP. Maybe I do. Oh yeah. HTOP's showing the exact same thing, but as you can see, HTOP is just cooler, right? Like just really, really cool, right? Different ways of showing the same thing, but top is usually there and running with it. All right. So if I want to get information on my IP address, I can do IP and it'll give me my IP address, right? So I can go IPA and now it's going to show me all of the interfaces that exist on my system and what those current IP addresses and MAC addresses are. Another way that I can do this is ifconfig. If I run ifconfig, I think it shows it in a little bit better format than IPA does, but that's just me. It has nothing to do with India Pale Ale. It's just IP, show me all of the IP addresses. And there's ifconfig. Ping, remember we were talking about people with really weird names, like they called it the touch command. Let me touch him, right? That's kind of weird. I don't know if you saw that meme, but it's an album cover that's hilariously bad, right? But if we want to see if a system is alive, not pig, I can do ping, and I can do 8.8.8.8, right? There we go. And now I ping that remote system. Now, does anybody know what ping stands for? Like that, we don't use a finger anymore. Ping pong? Nope. Nope. Packet Internet Groper. That's actually the name of the ping command. So I do, man, right? We've got the Packet Internet Groper. One of the problems that I have, in IT as a whole, and I think Megan's got the right idea, just keep our hands to ourselves, boys and girls. I used to have all kinds of jokes about whoever this person was that came up with the name Ping and called it the Packet Internet Groper. And one of my classes years and years and years ago, I had a student that sent me an email, and he was like, I really am offended by all the jokes you made about the guy that invented the packet internet groper. He was a family friend of mine, and he was a quiet young man, and he kept to himself, and he came over and then proceeds to describe, and literally describes him like every serial killer you've ever had described to you on the news, ever. Right. And I just thought that that shit was funny. That literally they're using, the groper was created by a guy who was quiet and kept to himself. It's like, wow. Okay. The other thing that I think is funny is in this industry, you have people all the time. They're like, we need more women in this industry. How do we get more women in this industry? Well, one thing, stop obsessing about getting more women in the industry. They tend to freak out about such things. And the other thing is, I'm just throwing this out there as an idea. Maybe we should stop calling tools gropers. Just, just an idea. Just something to percolate on as we progress through our communities and stuff. All right, open ports with Nmap. Nmap is just a really powerful tool. We'll have entire labs on this a little bit later, where you're able to identify what ports are open on computer systems. So in a second, this will come back and tell us we got 80 or 443 rather, and 53 open for DNS available and running. Now, one of my big things that I always tell people for troubleshooting is we really need to focus on how we troubleshoot. Ping, port, parse. Number one, can I ping the system, right? Can I identify if that system is available? Port, can I see if that port is available? And we can see that with Nmap. And then parse is parsing all of the different error messages that we receive or logs that we receive. So we need to get into that habit of ping, port, and parse. Network connections, we can look at network connections with netstat. Oh, can't type, but there you go. And when we get to when we get to the Windows section, we're going to see netstat again. It's like I feel like I need permission to ping now. Maybe we need to have a shirt that says "ping consent is important." Right? We should do that as well. I don't use netstat, like hardly ever on like ever. Instead, I use LSOF. So the reason why is LSOF stands for list open files. So if I go through and run LSOF, it's going to show me every single open file that exists on this system. And that is in and of itself very powerful. But as you can see, it's a lot of data that it's dumping, just a lot of data. So what we can do is we can restrict it. I can do LSOF minus I to show me any of the open internet connections. And capital P is going to just give me the IP address, or sorry, the port number. Don't try to tell me what that port is. Just give me the straight dope. And that's what it's going to do. So now it shows me all of the different, I've got DH client running. I've got container, SSH, VNC. It's beautiful. It's a lot simpler to work with. Process, I can go into the proc directory. We already talked about that, right? So we can go CD into proc, right? And we can see all the processes that are currently running. And we can dive into an executable, and we can run strings against that executable to look for like human printable strings. And we can find out what those programs do when we're in that executable file in the proc directory. Okay, now let's get real weird. If I do history, right? If I do history, it's going to show me all of the previous history and all the commands that I've ran since I've had this session open. It'll keep my old ones open as well, but I've got my full history is there and it's ready to see. So if I do John and then do history, you'll see I have the John command. But watch this. If I do hide me, it didn't show it. If I do John 2, or if I do ping 8.8.8.8 and then history, none of that's showing up. What's going on? Did a little magician sleight of hand. Anyone know? Some of you do know. Go ahead, you can share now. What did I do there? No one's typing. I didn't think my sleight of hand. There you go. Colling nailed it. I put a space at the front. So if you don't want something saved to your history, you put a space in front of it. So if I do space IPA, IPA, and then I do history again, you don't save it. Now, this is really weird. Why is this? So for me, I've always thought it a bit sus that it worked this way. The actual reason why is because if you're writing a batch script or you're running commands that include things like API keys for Amazon services, like let's say you're trying to connect into a Microsoft service and you're using an API key, or you have something that has a password built into it or anything sensitive, by putting a space in front of it, it means it's not recorded to the history. Do I think that's the way it should work? Hell no, I think it's stupid. But there is at least a reason, even if it is a weird reason, to run that way as well. All right, so now it's time for us to do a lab. Back to the lab again. Let's go back down to our lab directory. And we're going to do Linux command line. And this lab, if you want to queue it up, Daryl, is going to be 40 minutes. We're going to have 10 minutes for the break, 30 minutes to work on the lab, and then I'm going to do the walkthrough of it. We're going to be inside of our Kali terminal, and we're going to become root, and then we're going to do some weird backpipe shenanigans on it. So we're going to go through, and we're going to create this backpipe. What we're creating is a one-line backdoor on your Linux system. So this is a way for me to create malware super easily without having to go full Metasploit interpreter, which we get into in the next section. We create some malware for you all a little bit later. So it's a Linux one-liner to create malware. I'll walk through it slowly. We're going to get our IP address. We're going to connect to our IP address, and then we're going to run some commands. Okay. Then you're going to open up another command, and you're going to hunt for that backdoor. You're going to become root. You're going to run lsof to look for that process ID. You're going to cd into the process ID and proc. You're going to ls, and then you're going to strings out that executable in memory. So you can see that there's actually, like, this is a netcat executable, which is really helpful for starting your system and hunting it down, right? That's the lab. All right, so let's get to it. If you guys need anything, please don't hesitate to ask us for help.
You're muted.
I thought we were set at 40 minutes after. Isn't that right? Or how long? It says it's 11.
It is 40 minutes after.
The time must be a little bit off. Sorry about that, but let's keep going. All right, so what we're going to do is we're going to do this Linux command line lab really quick as unto a gazelle. I'm going to open up another terminal, and we're going to go ahead and change the appearance of this one as well. Excuse me. I was eating before we came here. I had a granola peanut butter fruit bowl. Let's open up another one. I'm just going to keep that one small. Doesn't really matter all that much. All right, so let's get started. So the first thing we're going to do is we're going to become root, because root is root. and we are going to already be root in this terminal. So we're going to type it anyway. And then we're going to do this weird thing. We're going to go make node backpipe P. So make node backpipe P allows us to create a special kind of file. It's a super neat file. It's called a FIFO file. FIFO, fee-fi, fo-fum, I smell the blood of an Englishman, but FIFO in this particular situation stands for first in, first out. Now, the reason why by the way, the P is what denotes it as a FIFO device file. The reason why these types of files exist is these types of files allow programs to communicate with each other without opening a network SOC to do so. So if you think about it in Windows, you can use pipes to transfer data back and forth via RPC. You can also do that on Linux using these FIFO device files, using named pipes. So make node creates the file, the P denotes it's a FIFO device file, and backpipe is the name of the file that we are creating. We could have named it Bill, Bob, Jim, whatever. So we just created the file called backpipe. That is a FIFO device file. Next, we're going to do our backdoor one-liner utilizing a tool called netcat. And in this particular command, what we're doing is we're invoking bin bash, of course, but it's weird. Well, I ain't doing anything with it. That's odd. How does that work? Well, we have these weird backpipes, and the way the backpipe works is it's almost like a magical teleportation device that allows us to shuttle data back and forth without that network connection. When you and I tend to read, we read, most of us on this webcast would read left to right. Now, some parts of the world, they read right to left. That's fine. You see that in Asian cultures as well. But if you're looking at this, I have data that I need to get from the right side of the equation to the left side of the equation. And to do that, I use a backpipe. Now, if you look closely, it looks as though there are 3 backpipes in my command. There are not. We are simply referencing the exact same backpipe 3 separate times. Now, what we're doing is if data comes out of bin bash, it's actually going to ignore these 2 backpipes. It's kind of weird, but it's going to ignore them and it's going to pipe it into netcat. And the reason why it's going to do that is because this little guy right there, that 0 less than symbol, the 0 stands for standard input. 0 is input, 1 is output, 2 is error. And what we're doing is we're taking anything that comes into the backpipe and we're putting it into bin bash. And the arrow determines the directionality that it's going to go. As we receive anything, it goes into the netcat listener listening on port 2222. If we were to connect on port 2222 on this little backpipe thingamajiggy that we have, let's go ahead and make that connection now. Go ahead and do that. If I do this, I do netcat 127.0.0.1 on port 2222. Hit enter, nothing happens at all. Unfortunately, in this situation, Linux doesn't pat you on the head and say, congratulations, you are a very good girl or a very good little boy, and you made a connection, and here's your shell. It gives you nothing because that's what's expected of you. And actually, to see this, we would type ls, and we can see that the ls command executed. If I do ID, the ID command executed. So we connected into our little backpipe one-liner, and we were able to connect on port 2222. When we ran the ls command, it takes it to standard output, puts it into the backpipe. Remember, all these are the same. And then it puts it into this backpipe, slides off that one, and it goes into bin bash and executes. Takes the output, ignores these backpipes, and then shoves it back out our netcat listener. Now, at this point, you might be wondering to yourself, oh, dear God, what the hell is going on here? This is insane. First, congratulations. First step to understanding how this works is to understand it's insane and not normal. The second thing is, please understand that this took a couple of the smartest Unix administrator hackers I have ever known in my entire life, about a weekend and a few 6-packs of beer to get it to work. So this isn't something that you have to look at and be like, yeah, you totally can get that. This is base level stuff. The only thing you have to know is that this is a Linux Linux shell one-liner. There's a number of them using Telnet and all kinds of different tools that exist. This is just one of them that are out there. But the question of this lab is, how do we go about hunting these types of Unix one-liners? So if I'm trying to hunt this particular one-liner, I can run commands like lsof minus lowercase I, capital P, and we can see we have this netcat connection right here. If I become root and rerun that command, that's weird. Let me go back and grab this command again. I just can't wait to run the command again. You can actually see the netcat listener is listening on port 2222, and we can see its process ID is 4746. So we see we've got that backdoor running and doing stuff. Now I can drive in on that process ID by doing lsof, and then I can put in that process ID of 4746. And now it's going to show me all of the open files associated with 4746. And we can see that it's, where it's executing from, what the top level directory is. This text file is the executable itself. And we can see that it's using a bunch of networking libraries to run. It's using a pipe. It's got a dev pseudotile type terminal, and it's listening on a network connection. So that's a lot. But we want to hunt that down. So what we're going to do is we're going to cd into proc, and we're going to go into that process ID, which was, I can't remember, 4746, 4746. And now let's say I don't know what that executable is. I have no idea. I'm like researching it, but I'm not 100% sure. I can do strings, and I can run it against the executable in memory. And it'll dump all of the human readable strings from memory from that executable. So eventually, if I go a little bit further down, I get information like what is the name of the backdoor. And in this situation, it says OpenBSD netcat and how to use it. Not bad, huh? Not bad at all. I had no idea I looked that much like Frodo. I mean, I'm sure AI did not have to work that hard to create that image. All right, so now I'm going to show you something cool. You guys want to see something cool? I mean, if you guys don't want to see something cool, I don't have to show it to you. Okay, so let's say I did a copy of user bin nc, and I copied it here. All right. So I now have a version of netcat that I can run here, and it's just straight netcat. I just copied it to this individual directory. And let's say I take my backdoor that I generated up above, and instead of running netcat there, I'm going to run netcat here. All right. So now I've just ran netcat here in this directory, and now it works, and it should work just fine, right? I can connect to it. I can make commands. I can do things. I can do all the stuff that I need. And you can see I've got the here program and all of that. But let's say that the attacker is getting a little groovy, right? Let's say they're neat. So what I can do is I can do rm here. So I can remove here, type ls. Now you can see it's not there. So here is no longer here. Here is no longer there. Here is gone. But my backdoor still works. So remember I was telling you how we can delete files and we can do all kinds of weird things. No, I didn't even use a dot directory. Here is gone. Here's not there anymore, man. Here's not there. It's gone. If I'm trying to hunt this, it's not even hidden. It's deleted. So how do I deal with that? So if I'm trying to deal with here in that particular situation, and we've got that going on, how do I deal with here being deleted like that? So what I can do is I can start hunting for here, thinking that it's not there. Because if it's not here and it's not there, it's got to be somewhere. So what I can do is I can do lsof, and I can do this weird command. I can say, I want to list all of the open files with a link count less than 1. And as you all know, for looking at computers, if something's less than 1, it's 0. That means it's been unlinked. So if I hit the enter key, you can see that here's not there. Here has been deleted. See that? It's been deleted. I have the process ID though. I have the process ID of 4959 because if here's not on the file system anymore and it's just not there, it's got to be somewhere. Where would here be if here's not there? Here still exists in memory. So link count less than 1. I did LSOF plus that said, show me all the files with a link count less than 1. That's what the plus capital L means. So that shows me all of the deleted files in the system. We can go deeper. I can go into proc, link count. Whenever you have a directory, think of a directory in files. Files are linked on your hard drive saying this file is associated with this directory. This file is at this specific link on the hard drive. When I unlink it, it is basically said that that section of the hard drive is available to be used at their earliest convenience, specifically when the process dies. So whenever you kill something, it's not really dead until it's overwritten. We've just unlinked it from the hard drive at that particular point. Okay, here we go. So now I can go proc or cd into proc 4959, type ls. Because my process is still running, here is in memory. Here is in memory, it's still running until I kill it. Once I kill this process, it blows away the file completely or it gets overwritten at that particular point. So what I can do now is I can still do strings against the executable, pipe it through less, and I can still see what's going on. You see, if the attacker is actively trying to hide files by deleting them from the file system, it will still exist in proc for you to be able to do research on it as well. I told you it was going to be weird. So, all right. All right, so that is the Linux command line. All right, so let's move into Windows endpoint analysis. Now we took that really weird sort of like still thing. Like, all right, so here we go. So here's not here, but it's not there until it's in the middle of nowhere. Now it's just in memory. I don't have any cool things to like get it set up there as well. Could you copy it? Yeah, you absolutely could. So what I could do in this situation is I could do copy exe into temp, and it just copies the executable into the temp directory, and now it's ephemeral. So even if it's deleted, I would still be able to pull it out of memory. There you go. All right. So Windows, when bad things happen, how do we deal with it? So we're going to get started with this a little bit. We're going to take another break in about 5 minutes. I'm going to do the walkthrough, and then we're going to do the lab. And actually, after the lab, we're going to do another Ask Me Anything tonight. You guys see, you guys seem to like the Ask Me Anything, which I'm pretty honored that you all enjoy that. I like it. I think it's cool. But on Windows, how do we deal with things when bad things happen? Now, at this particular point, some of you may be wondering, why did we do networking and Linux before we got to Windows? I mean, Windows is very much base to a lot of organizations. Why didn't we just start there? Well, I want you to think of all the things that we just discussed, right? We talked about networks, talked about ports, we talked about services, we talked about ASNs and all of these different things, IP addresses. And then we also used Linux as a kind of a little primer to get started by creating a little bit of Linux backdoors and a little bit of learning how Linux works. And the reason why we did it in that order is because by the time we get to Windows, now you're kind of got your feet under you for Linux and you kind of got your feet under you for networking. So a lot of these really important topics, you're not being introduced to them for the first time when we get to Windows. So Windows being arguably the most important section that we cover today becomes easier for you to digest and understand it. This is what we call a pedagogical technique. But what we're doing in this section is we're focusing, and the same thing we did on the Linux section is we're focusing on live forensics. If you believe a system to be compromised, what are the things that you can do to try to determine the extent or even find out if the system's compromised at all? So that's what we're going to be focusing on this section. What are the things that we can run? What are the things that we can do on a Windows computer system that are very similar to what we just did on the Linux computer system to be able to detect malware? Also with this, the one thing that I really like is we're going to be creating malware. So how many of you have ever wanted to create a virus in Windows? Huh? Anyone? Yeah, there you go. Most of you have, right? And for the record, what we're doing here for the people that listen to things on YouTube and determine which videos get banned, I just want to make it abundantly clear we're doing this for the perspective to better defend our networks and understand how malware works because the YouTube gods are angry. Just so you know, all of the major vendors that are out there from Microsoft to Google to Oracle, like they are not friends of vulnerability research. They are not friends of disclosure at the moment. Hey, on that note, do you guys want to see a Windows 0 day that Microsoft has decided to ignore? Anyone? I don't know. How about we do that? Right? How about at the end of class, I share with you, not necessarily a 0 day like a remote exploit, but a way that we hide malware at Black Hills Information Security from being detected and bypassing things like application controls. I don't know if the blog's out yet, but we'll use this just to kind of articulate the problem that exists when trying to deal with large vendors. So here's what we're going to do. We're going to take a break in a few minutes, but when we come back, I'm going to start with network connections. We're going to go through, discuss network connections and a multitude of different ways that we can analyze network connections on a Windows computer system. Looking at things like netstat, netview, netuse, netsession, and so on. So before we get into that, let's go ahead and take a break. Do we want to set the clock for 12 minutes? Because that gets us a nice even break. We get a 10-minute break plus 2 minutes for me to make a quick phone call. All right, so let's go ahead and let's set the clock and we'll be right back. All right, I am not muted. I'm just slow. It's getting worse as I'm getting older. All righty. So let's go ahead and let's get started. All right, so with the network commands, I'm going to close out all of this stuff right now because I don't really need it at this point. Can we open up a standard Windows command prompt? There we go. All right, so if we're looking at how we do this on Windows-based systems, we can start out with netstat. Now, if you remember, whenever we were working on Linux, I wasn't a big fan of netstat. Netstat by Windows in running that isn't a hell of a lot better, but it is better. It is absolutely better than the standard Linux-based netstat and what you're using. We're going to kind of show you the difference between netstat, netview, netuse, and netsession because it's more difficult to kind of parse when we're dealing with Windows systems, like which system and what is it being talked to? Is something else talking to it? What is the protocol? What are the services? What are all of those different things? Because the output is going to be different and the switches we use are going to be different as well. So let's get started. So NetView. So I like to use NetView because it allows me to look at what the shares that are currently available on the computer system are. A little bit later with our lab, we're going to be showing you how you'll use NetView to be able to see the shares. In this situation, I actually don't have any shares on this Windows computer system. Now, why am I interested in shares? A lot of times when attackers break into a computer system, they like to establish a beachhead on that computer system. And what they do with that beachhead is they exploit other systems, but then they pull files back to the first exploited computer system. And to do this, they'll have a share, right? So if I exploit machine A and I pivot to machine B, C, D, E, and F, and then I reach out and grab files, I'll pull them back to the staging system. I'll RAR up the files that I'm exfiltrating, and then I will exfiltrate them off of the computer system. Now, netsession is different. So on Windows computer systems, you've got to look at it almost holistically, I would say. Like, who's communicating with the system? Who's talking to me? So let's say that I find malware on a computer. Is that the primary system that's been compromised? Is that the middle computer system that's been compromised, or is it like an end computer that has been compromised? You don't know unless you run the right commands to be able to identify that. So if I do net session, it's going to tell me who is currently talking to this computer system. Once again, I don't have anything yet, but we will have a lab here in a little bit. We'll be able to make those sessions and make those connections. And the way I would do that is I would go to net use and I would do star 27.0.0.1 and I'll go $, right? So if I run this command, I have now made a session over to myself, making it from myself to myself, but it's all discombobulated, I suppose. I think we saw Austin Powers cross-modulating earlier today in one of the memes, but now I've made a session with this computer. Now, if I run net session, you'll see that session, right? So now I can see that, right? Actually, I don't have Zoom on this, so maybe I can within, I don't think my Zoom is zooming. No zoomies. So, all right. Sorry about that. All right. So net use is who is talking to us, the opposite direction. Who is the system talking to as well? That works if you are in a, or you're in a real system, but this is in a VNC guacamole session. So a lot of those Zoom things don't work quite as well. So net use shows us who we're talking to. So if I do net use, it's going to show me that I have a share mounted on the other system. And I'm sitting here hitting Control++. It's not going to do it. So we can see that I have that Z share. And to access the Z share, I would do Z colon. It only has one colon. And Control up. That's going to zoom my main system, which is zooming for me, but not for you. It zooms like a champ. I know this sounds weird. Zoom doesn't work in Zoom. All right. So netstat, with netstat, let me do C colon, come back here, and let's do CLS. We'll go to netstat. I already ran netstat earlier. It's telling me all of the different IP address connections that exist, and it's telling me if it's established. But the problem with this is I'm missing a lot of data, like a tremendous amount of data. I can't see the, let's see if I can do size. Nope, that's different. Let me go to properties, see if I can make this a little bit bigger. Terminal. Font. Here we go. Let's do this. There we go. There's that a little bit better for y'all. How about 24? There we go. Oh, there we go. That's much better. How's that? We good? All right, that way I don't have to do the weird Zoom commands and guacamole and all that. All right, so now I have all of the network connections that exist on this system, but I want more. I want to go deeper. I want to see a lot more with my netstat command. So what I can do is I can run netstat dash NAOB, NAOB, and let's go ahead and run that, dash NAOB. What does that mean? Netstat, we are going to, with NAOB, we're going to show all of the network connections, and we're going to see the process IDs and the executable associated with it as well. Watch how this changes everything. All right. It looks a little bit more complicated, but sit tight, right? So what we have here is we have this port is open, 3389. Now I have the process ID, and I know that that's Microsoft Terminal Services. Right? So that's pretty cool. I know that this next one says cannot obtain ownership information. What is that? Does that mean it's malware? I've got a process ID of 4. Does that mean that this process ID is malicious because I cannot obtain ownership information? No. With a number of the different processes that exist on Windows, certain processes will always say cannot obtain ownership information. And one of those is the system process. The system process is always running with process ID 4. But for literally everything else we have on this computer, it's going to tell us what is the process that is associated with that executable and that port on that as well. So yeah, you can zoom in and out on your mouse pad. You absolutely can, but you're not sharing your screen in Zoom. We're going to get hung up on Zooming. Zoom is one of the platforms for webcasts that if you try to do the traditional Zoom in and out, like right now on my Mac, I'm zooming, I'm zooming, I'm zooming. And right now, the only thing I see is one period. It's taking up like my whole screen. Zoom is not reflecting that zoom to you. All right. So it's different. So that's why we have to do it that way. All righty. So that's another way that we can look at the network connections. So we got Netstat NAOB gives us a lot more data insofar as what's going on. Netstat minus F is going to show us the fully qualified domain names. It's going to try to resolve. Now, this one is interesting as well. So if I do netstat minus F like so, it's going to try to resolve the foreign address. So if I give it something to resolve, so let me go ahead and open up a browser, you're going to see how it's a lot different on that as well. I'm going to go netstat minus F. There we are. And on a lot of these, it's going to try to resolve it back. So we got Microsoft Edge. We have a whole bunch of here at Akamai Technologies. We got established connections. It's going through and it's setting that up for us to be able to get in and resolve those, which is really, really helpful for that as well. There we go. All right, so next one, Windows processes. So we're switching from network connections and we're moving into the actual processes themselves, right? How do we dig into those processes and try to figure out what's going on? We're going to start with like the worst command ever. We're going to go to task list. We're in task list by itself. Got all these things running on this system. It's kind of odd. Hmm. Does anyone have any idea what would be a good name for a piece of malware on my Windows system? If I was going to try to create some malware on my Windows system that might blend in pretty well, what would be a good name for it? Yeah, SVC host. SVC host or services controller host. One of my favorite things is people doing research and they're like, is SVC host safe? Is it malware? And it'll be like, its service controller host is legitimate. It's not a virus. However, it says sometimes it can be. So what you can do is look at Task Manager to figure out if it's malware. I don't, I don't know. But I still have this problem of all these processes running, and I don't know what the hell the SVC host actually is. So what I can do is this. I can do task list space / SVC. Now it's going to show me all the processes that are running and any of the ones that are associated with a service that is started by SVC host. It's going to tell me what that service is. So if we go to our big C of different SVC hosts, you can see services controller host. This one's running LM host. This one's running terminal service. This is running NSI, DHCP, Ascend schedule, DNS cache, font cache. We can now get a list of what all the service names are for every one of those SVC hosts that exist out there. But wait, there's more. I can do task list space / M. Now I can look at all the dynamic link libraries that are associated in every single executable. Now this becomes important because if we're looking at different tasks and things that are running on a Windows computer system, being able to see these dynamic link libraries becomes powerful because if we don't know what a process is, if we can look at the dynamic link libraries associated with that process, it can help us reverse engineer what that service or that process does because different DLLs have different things that they do. This is going to become critical when we start creating our malware in just a little bit because some malware specimens will be using like the same dynamic link libraries again and again and again. The name of that command was task list space / M. Task list space / M. Now, if you want to flip it on its ear and you want to look at all of the processes that are using a specific dynamic link library, I can do that, right? I can run. So I can say, I want to see every process that is running the ntdll.dll dynamic link library. This is the Windows kernel, and I can look at it from that way. So if you see any dynamic link libraries that are a little bit sus, a little bit weird, you can also flip it, and you can see, is that dynamic link library used by any other executable on the system? Now we're getting a little weird. If we want to see all the dynamic link libraries used for a specific process, which we will be doing in a lab here in a little bit, we can do /M for the dynamic link libraries. FI stands for filter, and then we can do PID equals the specific process ID and get all of the dynamic link libraries loaded into that process. Next, we can do WMIC, process list full. And WMIC is about ready to be deprecated. Well, as a full command, you can still use WMI. But if I do WMIC process list full, it's going to show me all the processes, how much memory is being used, what's the base image associated with it. But the full WMI command line is being deprecated. It's going to be, you can still do WMI within PowerShell, but on a lot of versions of Windows, it's still there. Still use it. We can also get the parent process ID. So this helps us identify which process begat which other process, which begat the other process. And the Lord looked at it and said it was good with all of the begatting. So we can see that process hierarchy of which processes started which other processes. We can also get the command line invocation. All of this is interesting because what we're doing here for Windows Live Forensics, we're also going to do again with memory forensics, because a lot of the same types of troubleshooting and depth that we're going to be looking at, we can look on memory file as well using tools like volatility. All right, that brings us to the Windows Command Line Lab, the last lab of the day. Go, close that out. So we're going to do Windows CLI is the lab we're doing. Thank you very much, Jesse. So Windows CLI, we're going to open up a Kali command prompt on our system. And then we're going to disable Windows Defender. So let me pull something here real quick, just because a lot of times when we're doing this, people are like, well, you're disabling Windows Defender. And that seems lame, because you're disabling it. So I'm going to explain a couple things, and I'm going to share something with you here real quick. All righty. Let me open this in Word. So Black Hills Information Security, we bypass antivirus engines. It's what we do. Okay. And for this lab, we're disabling AV. And the reason why we're disabling AV is because if we did a lab on how to bypass AV, that lab would literally work for a day and it would never work again. Or would it? All right. So we're disabling AV because the goal of this is not to be like, here's how you bypass AV and all these things. The goal is how do we hunt malware on a system? So as an exchange, I'm going to give you a quick preview of a blog post that we are going to be releasing here shortly. This is research by Matthew Eisenberg at BHIS, or Heidelberg at BHIS. He is one of our malware developers. And this is a vulnerability that exists in something Microsoft uses called WebView 2. Okay. So in this particular vulnerability, we can actually load dynamic link libraries. See that dynamic link library thing? We were just talking about it, the DLL thing. Yeah, that's here. We can put dynamic link libraries in specific directories associated with WebView 2. And when WebView 2 applications run, it allows our malware to execute. And because these are all sandboxed from each other, it allows us to bypass certain things like application allow listing and visibility by some EDR products as well. So we can do like a full Cobalt Strike payload and get that running. And by the way, this works in Microsoft Teams, Outlook, all of the Outlook Office apps, Windows widgets, Visual Studio, and I think Snapchat as well, not sure. But we have that, and this is going to be a blog that will be released here in the next couple of months. So yeah, we sit on these things. Another way that you can get malware to execute on a Windows computer system is you can download it from the Microsoft Store. Yeah, I know that this sounds really interesting. Yep, that is the WebView 2 that Microsoft Teams uses. That's it. We also have the disclosure timeline for this as well. Where is it? We did disclose it to Microsoft. We disclosed it to them in September, and they just recently said, we don't care, we're not going to fix it. So if you're wondering why is John talking about this in a class, like, isn't this dangerous? Yeah, we do think it's dangerous, but Microsoft doesn't seem to think so. So we've been using it since September in our environments. So there you go. How's that for a trade? The other way that you can do it is download something from Microsoft Store, like download an alternate version of PowerShell from Microsoft Store and use that to run your malware, or Python as well. So there you go. All right. So, but for this lab, our goal is not to bypass. For this lab, we just want to play around with how we detect malware as well. So you're going to disable your firewall as well. You're going to set your administrator password to be password1234. Now, straight talk between me to you. This is important. Do not refresh your browser after you change your administrator password. If you do that, then you're not going to be able to come back in. You're going to have to blow away your cloud environment and start from scratch. So we're setting the password for administrator. Do not refresh your browser. Okay. Then we're going to get our IP address on our Windows computer system. Then we're going to become root in our Kali terminal, and we're going to start up with Metasploit. And we're going to use the most heavily used exploit in Metasploit called psexec. psexec allows us to use existing credentials, and it allows us to authenticate to a system to upload the malware to the system. So we're going to set the payload to be Windows Meterpreter Reverse TCP. We're going to set the rhost to be our IP address of the Windows computer. Remember, your IP address will be different. Then we're going to set the SMB username to be administrator. The password is going to be password1234. And then you're going to run exploit. It's going to authenticate to your Windows computer system and then upload and execute the malware to your Windows computer system. Then we're going to turn our hats around, just like over the top, huh? Sylvester Stallone references over the top. It's a hat thing. It was in the movie. It was at the 80s. It was a weird time for middle schoolers everywhere. All right, so we're then going to flip our hat around, and we're going to start hunting that malware, and we are going to run netstat NAOB to see that malware. Then we're going to dig deeper with netstat -f, and you're going to see that does not resolve. Then you're going to run taskless /m/fi/PIDEQ, the process ID in question. Then we're going to get the command line invocation. We're going to get the parent process ID as well. This is actually a really long lab. This is going to take us 1 hour to get through. We got a 10-minute break. It's a big lab, lots of steps, and I'm going to do the walkthrough first thing tomorrow morning with everybody. So let's go ahead and set the clock, Daryl. At 1 hour, we're going to do this lab. And once again, if you start getting angry red errors, it's because you refreshed your browser. You're just going to have to blow away the VM and Cloud Labs and start over. It's not that hard. It doesn't take that long. All right, so let's start the clock. You guys thought I was going to be late again, but I'm not. All right, so we are now at the point where we are moving forward with the Ask Me Anything. Tomorrow I will do the walkthrough for the lab, for the Windows Live forensic stuff that we were discussing. But at the moment, we're moving into the Ask Me Anything. I've got one of them, Killer Mind Hacker. Is AST similar to quite recognized in the industry? No, we are not. We are nowhere near CompTIA or ISC squared, but we're small and scrappy. But more important, the people that are actually hiring that you want to work for, they know who we are. Trust me, the cool kids know. And once again, it's a very cost-effective certification, and you should look into getting into it and giving it a shot. What is the most effective security control you run across when penetration testing? I would say it's love. I would say love is the strongest defense for any network anywhere. Other than love, I would say really good password and two-factor authentication policy would be absolutely essential. The organizations that we tend to break into, we're realizing now that identity is the new perimeter. So if you have anything that doesn't have 2FA, it's pretty much going to get hacked mercilessly. But having the two-factor authentication really slows down a large number of attackers. Now, there's a lot of variance to that. and subtlety, like SMS two-factor authentication, things that can be intercepted with evil jinx, to proxy authentication to steal credentials. There's a lot of ways to get around that in the modern industry today, but it's more difficult. So really that is critical. Second to that, or third, I would say is a good external patching and vulnerability assessment strategy would be right there as well. What's your view on secure boot? Do you think a Linux VM really needs the mechanism? Well, I get that certain kernel modules shouldn't be loaded without being certified by either the OS maintainer or manufacturer, preventing those things, la 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 la, yada yada, skippy hop. So resonating, what you're running into there is the fact that the industry, a lot of people that decide what computer security does are academics. And I don't have a lot against academics, but now I'm going to rip on them for a little bit. A lot of people that are in academia, they kind of have this very kind of ivory tower view of what computer security is. It's like, well, it's all about crypto and security models, and they get really hung up on old technologies. I have one project that I'm working on for DoD where they're absolutely terrified of attacks that really haven't been a thing since 1999. Like they're like, oh, really critical that we detect port knocking. What? Like that? Okay, yeah, that's, attackers don't, yeah, whatever. But they really get focused in on these things because they're not in reality. I'm just saying, not all academic people are like this, right? But a lot of times I look at academia as sitting in a car that's not driving anywhere and not on and making vroom vroom noises and pretending like you're actually doing something. Realistically, you need to get out there and do stuff. We see this again and again. Now, there are exceptions. There's a lot of really cool academic research that furthers information security quite a bit, but I would say 98% of it is like garbage. And this is actually in line with Kuhn's structure of scientific revolutions. Almost any industry, you have 98% is just reinforcing existing models, and that 2% is really what forward and like changes things dramatically out there as well. Um, what attack techniques do real threat actors use that SOC teams often miss? Cloud. That also goes back to the identity side. We spend a lot of time talking about endpoint and operating systems and things like that. And I've got a couple of labs that I think we're going to add in that's going to be all about how we can do cloud level analysis and what tools we have that assist us in doing cloud level analysis. But it's absolutely essential that we start looking into things like, Scout is a really, really solid tool. And then also we're looking at Graph Runner is one of the main tools that we'll be talking through as well. So we're going to be incorporating more labs in all of my classes dealing with cloud-based technologies. But the reason why I say this is because a lot of the cloud stuff that's out there has really crappy logging. The logs are back, they're not hitting right away, they're not popping in fresh, we don't have the right logs, or they're just flat out non-existent as well. All right, what else? You like Kali? Linux is a good cybersecurity OS. Honestly, I don't care. In fact, if you look at where we're heading in this course, with the VM lab. This particular virtual machine set that we are using, we have Kali, Ubuntu, we have Windows servers. We're actually moving to the anti-lab code is moving to an Ubuntu system. This anti-siphon practice lab is just an Ubuntu system and a Windows VM. So we're kind of moving off of Kali. And honestly, once you learn how to use Linux and use it properly, the actual operating system itself doesn't matter all that much as well. When doing the cert, is it timed? There are timing restrictions. Once again, if I go to CTF competitions, and I go to the core certification. You have the exam, it's 2 hours to complete that. And then after you're done with that, you have to get the next step done. You have 5 attempts. I don't think we bound it for writing the reports, but it's not bound all that much. But check it
Give
out.
them a little bit more information about the reports because,
Yes. All
yeah,
right. So whenever you're
explain
looking at
that
the
part.
reports here, let me pause sharing for just a second. And let me see if I got a report here. That's text edit. That's not what I wanted. Let's go to downloads and do a search for Fernando. Here we go. So this is like the level of reporting that we have at BHIS. I don't want to open a PDF Reader Pro. That was a mistake. Let's open it with preview. There we go. And we're going to go full size, enter full screen, and I'm going to resume share. So this is a report, and I can load it up in resources at the end of class. This is a report that actually got Fernando hired at Black Hills Information Security, and it really highlights what I think you should be doing in your report. Now, remember, I'm not going to grade your report. I hate that. I'm not going to go through and be like, your report could be better with using a certain past tense, present tense, imperfect tense, whatever. I don't care. But you got to understand your report is your proof of work. It's your proof of who you are. So if somebody wants to interview you, they're going to open up that report and they're going to look at that report. So if your report is written in wingdings and crayon, your report's going to be in wingdings and crayon, and that's going to be representative of who you say you are when you're going for a job. But if you want to get an idea of good things, lots of screenshots is essential. Screenshotting and doing call outs to what you actually see is critical. If you have any opportunity to write any code and show that you can think in code, that would be very important. In Fernando's report, he did Bash, he did curl. A little bit later on, he did Bash, curl, and Python. And this was very important for us because we saw that he was very flexible in his capabilities. If you want more understanding of how to report on these things, we have a really great webcast that we've done with BB King. It's called Testing for Show, Reporting for Dough. And these are out on YouTube and they are freely available. But I'll give you an idea of the level of reporting that you should strive to achieve on that as well. Somebody just said, please don't forget to destroy your virtual machines to conserve credits. I think that that's a very good idea. So let me go to my Cloud Labs. Let me go to SOC Core Skills. Actually, I think all of mine are off. All of mine are off. So I'm doing good there. I am doing good there. All right, I've been in the SOC for about a year. I'm trying to get into pen testing. I've been in tech for 8 years. Awesome. Would you recommend a skill set wise from SOC to Bragg to get into pen testing? I would really highlight your understanding of the MITRE attack technique matrix and what the different attack methodologies are. That is something that's really just going to highlight and show your capabilities and how they can be transferable into the pen testing realm. Do you all have a list of pen test interview questions for SOC Purple Team? No, I don't actually. But I know someone that can, our good friend ChatGPT and Anthropic. They probably come up with some really killer questions for that as well. All right, what do we got here? For someone who worked the last 10 years mostly on consulting on the defensive security, product and vendors would like to improve in different areas. Would you like to recommend? I think you're in the right area. You want to see something cool? I keep saying that, right? I need to make sure that I'm on the VPN. Am I on the VPN? Okay, I need to make sure that I'm connected. I am. All right, so just give me a second. Let me go to Teams. Let me go to Tim over here. I want to show you something neat that we're working on. It's just about done. I might be able to get you all into it as beta testers. This is the thing I was telling you about. Like, do you want to see something cool? Here it is.
Somebody said do a kick flip.
Kick flip. In this closet? I don't think so. All right. So this is Backdoors and Breaches Competitive Online. Let me go ahead and sign in. Okay, go ahead and save that. So this is competitive backdoors and breaches. And what this allows you to do is it allows you to create your own deck of backdoors and breaches. Like, let me go through. Should be able to create the deck. No, I don't have access to it. What's going on? All right, I can go to the cards. But all of the different types of cards that you can create and everything that you can learn is present and accounted for here. Okay. So this gets wicked cool because I can look at all of these different cards and I can be like, okay, compromising a web server or credential stuffing. And I can click that card and I can get the information, server analysis, this is how you detect it. Server analysis, user entity behavioral analytics, cloud event log analysis, SIM log analysis. These are tools, CredMaster, Burp Suite, Hashcat, and Hydra. And if I click on the back of that card, it gives the detections, gives the tools, and it also gives us the capability to download an example for it. Let me go to a different one. Let's go to phishing. If I flip phishing over, this one has attack tools and it also has related labs associated with it. So we are building up this game where you can play it competitively against other people, but you also have the ability to learn how to do all of the tools that they're talking about. So if we're talking about initial compromise, as we talk about here, we have a lab for Beelzebub. We have the email phishing lab. We have the evil jinx lab. We have the go fish lab. We have the other go fish lab. We have Maloney lab, and we have the social engineering toolkit lab. And every single one of these has step-by-step instructions on the new Ubuntu VM that we are building up for this class on how to do that specific thing. So in this one, you're using Sublime to be able to analyze a lab. This is one where you're using Beelzebub for cyber deception. This one is how do you set up Evil Jinx, which isn't done yet. Getting into the Ubuntu VM, how to use the Go Fish framework to start up like your own example phishing framework and setting up an example fish and how that looks from the pen testing side. This one is Maloney, low interaction SMTP honeypot, and this one is the social engineering toolkit or Welby. We right now have over 219 labs. 219 labs. When we're done, there's going to be over 300 labs associated with this. And our goal in doing this is providing people with a free environment to learn how to do these things and develop these skills. And you'll get 2 free hours per week to be able to practice these labs. So eventually it's all going to be part of what we call our Free Lab Friday initiative, where I'm going to start creating YouTube videos for every single one of these labs and tying it to the backdoors and breaches cards out there as well. So just a lot of cool things. Now, if I try to play to competitive, I don't see anyone is playing right now, but you can actually play this game, and we've introduced a new set of cards called the competitive cards. And these cards are kind of like something for Magic the Gathering or something like Dominion or Here to Slay or any of those games. So this is where your deck building comes in. I have some of my faves. This is one of my favorites, CTOs on ketamine. You get 2 extra resource points and you get an extra action, but you build your deck doing this. So if you're trying to learn security and you're trying to learn the fundamentals, we're trying to create this environment that is without question the best environment in the world to learn these things. And we're trying to occupy this space where we have people that do videos like John Hammond and IPSec and all these amazing people, Jerry Auger, who do just amazing videos, and you watch them do cool shit. And then you have CTF challenges, right? Where people are doing CTF challenges. There's a huge gap between those two things. And we want to occupy that gap to get people leveling up their skills, the tools that they have. So all of this is stuff that's coming down the pipe. And I think we're going to be able to release this beta in the next couple of weeks. I think right now what they're doing is they're trying to set up. I think that they're trying to set up the tier system. So we're trying to set it up so we have like a bracket system, like March Madness style brackets, so we can set up competitions. So this is one that's going to be coming out here in a bit. The other thing that's going to be happening is we're going to create like a competitive version where you will only be able to play the cards, the actual attack cards, that you have solved a cyber challenge associated with it. So there'll be labs associated with it, and then you'll have to solve a certain number of cyber challenges. And once you get those challenges, you get a code to redeem the card. So if somebody's playing, their deck is going to be based upon what they've actually solved in CTFs out there as well. So stay tuned. All right.
So with
No,
that, John, I have a question.
yeah.
This is just for my own knowledge. So when we launch this, are we going to do like a webcast?
Oh, yeah.
Or are we going to do like a big, like just an announcement on the anti-siphon? Okay.
We're doing a huge webcast. We're gonna roll
Okay.
this out. Yep. And people will be able to register to it with their own email. I've got to change my password. At least I hope they set my password for me. It's
Yeah.
pretty easy to guess.
Yeah.
But right now, the only way you can get to this is through the VPN, which means the only person on right now that can get here is Megan and Daryl. They're it.
Yeah.
They're the only ones
Yeah.
that can get this. So
Okay, so cool. Everybody keep an eye out for the announcement for the webcast and join us and get in there for the free lab Fridays.
So lots of cool stuff. And once again, I have people that get really down. They're like, well, AI is going to make us all useless now. No, no, the techniques still are there, right? We still have to understand the techniques, and AI is just part of that, right? So, right. That's why that IP doesn't work for me. That would be a correct assessment. Yes, that would be a little bit nervous if you could get there. Right. All right, everybody. I think we're going to lock it down today. I will see you all back here tomorrow morning. Thank you very much. And like I said, I'm going to go through and do the walkthrough for the Windows lab, and then we'll get through the rest of the class. So thank you so much, and I'll see you on the flip side.
All right. Okay, everyone, have a good evening. We will see you tomorrow for day 3 of SOC Core Skills. Make sure you keep coming back. We will have bingo on Thursday, not Friday, which is day 4. So hopefully everybody has a good rest of your day or evening, and we'll see you back here tomorrow. All right, Daryl, it's time. Go ahead and kill it with fire. Have a good night, everyone.